Hello everybody, this is Justin Young here, and I'm here today to show and tell about the makeup and geometry of the compound 6-amino 1-hexanol. But before we can actually go into anything about it, let's start off by assuming we don't know anything about the compound except its name. How do we know its formula? How do we know how it will work? How do we even know what it actually is? And we can tell all that from its actual name. Let's first look at the last part of it, 1-hexanol. That tells us two main things. And that's one, that it's a hexane, meaning it will be a 6-carbon molecule, and that it ends in all tells us that it will be an alcohol, which means it will have a hydroxy group attached to it. The one in front of it will tell us that the hydroxy group will be attached to the very first carbon within the 6-carbon molecule. And let's look at the beginning part of the name, 6-amino, which tells us basically almost the same thing as the hexanol part, or for the hydroxy group, but instead for an amino group. And this time it will be at the 6-carbon or the end of the compound instead of the beginning of it. So with that in the way, we can figure out another thing from that, which is the formula of this molecule, which will be C6, which means 6 carbons within it, H15, which means there will be 15 hydrogens in it total due to the bonding, and NO, meaning 1 nitrogen and 1 oxygen. So let's start off with the hydroxy group, since it will come before the first carbon, since it is 1-hexanol. Got our oxygen right here, connected a hydrogen to it. Since oxygen only wants 2 bonds, we will only need 1 hydrogen for it. And let's connect it to a carbon, which will be represented by these little black Snatoms right here. And like I said, it was H15, which means the carbon will more than likely end up with 2 hydrogens on it before connecting itself to another carbon. And this will likely go on for the entire molecule until we go through all the carbons, creating this handy look to it, kind of like a caterpillar in my eyes. And it will just keep going like this until we eventually get to the ending of the molecule. As you can see here, let me get this a little better in frame. You can see the beginning part of this right here will be the hydroxy group, which is attached to the first carbon, such as the name 1-hexanol, which will, since as you can see, this carbon is only attached to one other carbon, this makes this a primary alcohol group. And as you see, it keeps going down in this change, each carbon connects to the other carbon until eventually we get to the amino group. And as we hear, the nitrogen has 2 hydrogens connected to it, and it's only connected to 1 carbon, making it a primary amine group. And as you see with the geometry here, each of the carbons have a pretty bent shape to them as they're going into a chain, and that will be because of the actual hybridization of these carbons, which is all sp3, which that means that there are only sigma bonds within each of these molecules. As you can see, each carbon is only connected to, each carbon has 4 bonds, meaning it cannot hold any pi bonds. So we'll have a sigma bond to a carbon, then to another carbon, then to its 2 hydrogens up here, which leads to its overall chain shape.